Hello everyone. Myself Pranjal Choudhary, a student of final year BTech, currently studying in GH Raisoni College of Engineering and Management, Pune, in Department of AI and DS. So we have created a impressive project text to 3D animation conversion under the guidance of Professor Rahul Navale sir, with the help of my colleagues Soham Naik and Aditya Panchal. Further, in this presentation, we are going to cover the following topics: test justification, introduction, problem statement, application, literature survey, block diagram, motivation, expected result, work plan, and references. So, we have the core functionality that the primary goal of the project is to convert textual descriptions into 3D model. We have used the technology stacks such as Python for the backend development and the libraries from the Python. The title succinctly describes the key elements of the project, making it clear to the reader that the project contains the primary technologies involved. So, as part of introduction, I would like to give an overview of the project which we are going to study in the further presentation. This project aims to build an AI-based system that generates 3D model for textual descriptions. The core technology is Shapey, which is a library of Python, a model developed for text to 3D transformation. Our purpose is that 3D modeling, which is critical in many industries like gaming, education, prototyping, and manufacturing. However, existing tools are often difficult for non experts to use. So, our project focuses on generating models from user input text prompts, which develops a user-friendly interface where users can enter descriptions and get immediate 3D output. Demonstrates potential application in education, entertainment, and prototyping. So, our main problem statement focuses on the traditional 3D model creations. The traditional 3D model creating applications such as Blender, AutoCAD, Maya, these are very hard to learn. These tools take years of practice, making it inaccessible to the non-expert to use. They are very time consuming, costly, especially for the tasks like rapid prototyping or small scale design changes. These projects have lack of accessibility, that is 3D designing tools are not intuitive and their cost can be prohibitive for hobbyist educators or small businesses. So we have created a purposed solution by introducing a text to 3D system. This project eliminates the need of manual 3D modeling, allowing anyone to generate high quality models quickly and effortlessly for simple text inputs. Our model have multiple applications such as for enhanced visualization for education and training purposes. In education, such as there are difficulties in visualizing complex concepts and objects described in text, which can be converted into 3D models, making learning more interactive and comprehensive. Then on second point, we have rapid prototyping for designers and engineers. The designers and engineers have very time consuming process to manually create 3D models. So they can just put in a text description in a model which can create a 3D image for them which they can use in their further phases. So for user experiences such as in gaming and virtual reality, which is completely based on the three-dimensional assets for descriptive text, enriching the content creation, processing in gaming and VR. Improved content creation for storytelling and media, whereas difficulty in translating written narratives into visual media converts descriptive passages into 3D models, aiding in development of visual content for films, animations, and interactive media. These are some of our literature surveys that are text to 3D conversion using NLP and 3D modeling from John Dewey, then zero shot text to image generation, SharpNet, learning transferable visual models from natural language and supervision. This is the block diagram of workflow of our code, wherein first we have to give an text input, then it will be diffused by the Shapey diffusion model. Then later it will be given to the latent processing and decoding, which will then move them to the further second most final step of rendering and visualization. Then it will be saved, it can be saved or export. So I can illustrate the code and the module right away in next slide. So here is our code, which is first, this is git clone. We have cloned the Shapey library in our project, which is used for 3D modeling, designing 3D modeling. Then we have made it to copied the repository to our project folder. On the second part, we have installed the required packages used for our project or for Shapey. Then we have imported torch library for Shapey diffusion samples, which import sample latents. And then the further processes. This is our device torch. Going on to second part of load module and to module conversion, which is used for diffusion. So as you can see, the diffusion is completed now. Further moving on to the main part. Here, this is the size and gradient which can be regulated by what size or shape do you want your 3D image. So first we have to put in a prompt. Let's take an example of a cricket bat. After the diffusion is completely done, we will go for the runtime of the prompt. So the final step of diffusion is completed. Now let's run our prompt. Here it is processing the prompt. As you can see, the processing of the description has come to an end. Now it's time to render the model. So here it comes, it is rendering the model. So this is our desired output which we are expecting of a cricket bat. Moving on to the further slide. So where did we get the motivation? That is, first is democratic 3D modeling. The traditional 3D modeling has been restricted to professionals with specialized knowledge. With this project aims to democratize the process, making it accessible to the wider audience, including educators, students, small businesses, and hobbyists. Efficiency and automation, that is, manual 3D modeling takes hours to complete, but by the automation, this project takes very less time as compared to the manual 3D modeling. The cost reduction, which we can see the other software which are used for 3D modeling are very expensive. They have expensive license and long training period are offered for required 3D design. And our project also have innovation potential. The application of AI in 3D modeling is yet to open up. So we have created a new possibility for creative and customization as per the user can generate an infinite numbers of unique models based on sample descriptions for testing innovations in design and prototyping. Yeah, we get the input, that's the output. So this was our work plan. That was in July, we did literature reviews and requirement analysis. In August, we started with designing and experimental analysis. In September, we were done with experimental analysis and we started with module wise implementation. Now in October, we did with the last part of testing, debugging, preparation of project report and thesis writing. And it's now November where we have done with our project report and thesis writing. We have taken these of the references. Thank you.